Hi, Algebra 2. This is the second video that goes with the first video on inequalities with one variable. This is going to be graphing linear inequalities in two variables and solving systems of linear inequalities in two variables. So make sure you watch the first video first. We're going to just review a little bit of graphing first. So go ahead and pause your videos, write down the problems and try them, and then check your answers with me. All right, so here we go. Just a quick recap. Check your work. This is just in y equals mx plus b, right? So we started at 6, and then we had a slope of positive 1/3. For the second one here, our point was -3, 4, according to our point slope form, which is, whoops, minus x sub 1. Okay, and so we just applied that point and then applied the slope of -2. Over here, we use x and y intercepts when we have standard form. So really just covering up the x and figuring out when x is 0, what is y? Well, that would be -6. Covering up the y, well, if y is 0, what is x? It's 9. Graph those 2 points and draw a line between them. All right, moving on. So when we're graphing and solving a system of linear inequalities, we graph the corresponding equation in slope-intercept form using a dashed line for greater than or less than, and a solid line for less than or equal to, or greater than or equal to. I just always think of it as it can't actually equal anything on this line when it's less than or greater than, so it's dashed. When it can equal anything on the line, then it's solid because that shows all the solutions. We now have to have two planes, so we test a point to find whether the solution is a solution to the inequality, and then we're going to be doing some shading. So some of you probably remember this from Algebra 1, but take it slowly if you don't, and do a lot of pausing and checking. Let's move on. So how do we graph an inequality? First, we just treat this like an equal sign, and we see that it looks like y equals mx plus b, right? So we're going to start at -3 for our y-intercept. And then we're going to go up 2 over 1 and up 2 over 1. At least 3 points is always what we try to get. And then we have y is less than 2x minus 3. So if we find a point on the inequality, this is going to be a solid line, first of all. So it's a solid line because it's less than or equal to. And now we know the solutions either lie on this side or on this side. It's not just solutions on the line like when we graph linear equations. So we need to test a point. The easiest point to test, I think, is 0, 0. And 0, 0 is clearly not on the line. So if we test this point 0, 0, it's going to tell us if our answers lie on this side or the other side. If 0, 0 works, then all of these are solutions. If 0, 0 doesn't work, then the other side is solutions. So plugging that in, 0 is less than or equal to 2 times 0 minus 3. 0 is less than or equal to 0 minus 3. Is 0 less than or equal to -3? That is false. So solutions do not lie over here on 0, where 0, 0 is. What happened to my pen? So where's my pen? So we are going to shade in this side. Well, maybe we are. We're going to shade in the side that has the solutions, which is this side. Okay, so all the solutions can lie on this line or below it. Next one. Practice these 3 again. I'm going to kind of walk you through the first one, and then I want you guys to do the second one, the second 2 on your own. So looking at this equation here, we have point slope form. So the point that we want to take from this is going to be -8, -5. So we'll go -8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5. And then we're going to go down to over 1 down to over 1, at least 3 points. And then we've got less than. So this is actually a dashed line. And remember, if you have issues graphing, you can always make a table and plug in points. You don't have to remember how to graph all of these, I would say. It's the easiest way to do that, but you can always make a table. So don't forget that strategy. And now we want to test a point, and I can see 0, 0 is way out here, so that's a good point to test. So let's do 0, 0. So when we have y plus 0, or whoops, not y plus 0. When we have 0 plus 5, 0 plus 5 is less than negative 2 times 0 plus 8. So on the left-hand side here, we get 5 is less than 8 times negative 2, which is negative 16. Is this true? No, it's not. It's false. So there are no solutions on this side. So we need to go ahead and shade in the other side. Okay, so why don't you guys pause, do numbers 3 and 4, and then come back and check your answers. All right, so here we go. In this guy here, we have standard form, so graph the x and y intercepts. When you graph those, go ahead and test the point 0, 0, and 0, 0 does work, so our solutions are going to be over there. Next one, y is greater than negative 2. So if y is always negative 2, then we know we're graphing a horizontal line. And then it makes sense that if y is greater than negative 2, then all of our answers would be up here. But if you plug in anything like that, like 0, you can plug in 0. 0 is greater than negative 2, true, shade above. All right, go ahead and pause if you need more time on those answers, and we're going to move on. So graph the solution to the system of inequalities that is called the feasible region. So now we have 2 inequalities that we're going to graph, and then we're going to find where the solution set is or where the feasible region is. So first, y equals mx plus b up here at the top. We're going to start at 6. 1, 2, 3, 4, 5, 6. And we've got a slope of negative 2. So we'll go down 2 over 1, down 2 over 1. We'll do one more just because. And then we have a dotted or dashed line here because it is less than, not equal to. So then let's do this guy here. So we'll go up 1, and we've got a slope of a half. So up 1 over 2, up 1 over 2. And this guy is going to be a solid line. It's really hard to draw, guys. Okay, and we have that there. Now, what our job is to do is to find out where we have a solution. So what side of each line? So if I'm going to test, if I'm going to test this, I'm going to plug in 0 for here. I got 0 is less than negative 2 times 0 plus 6. That does not look like a 0. So we'll have 0 is less than 6. Yes, that's true. So for this equation here, which is our dashed line, we know 0, 0 is true. So what happens is all of this is true for the purple line, right? Okay, now we need to test the other line. So the other line, our red line here, we need to plug in 0, 0. We'll have 0 is greater than or equal to 1 plus 0.5 times 0. So is 0 greater than or equal to 1? No, it is not. So for our red line, we are going to shade above it. So we're going to shade up here and up here. Now, feasible region means the region where both of them are true, right? So we have all of this region up here, and the other regions are actually not solutions when we're talking about the system. If it was just the line, yes, those would be solutions, but we have 2 lines, so we want to make sure we shade where both of them show solutions. So that would be all of this over here. Now, when you're thinking about this, think about this point here. Is the intersection 2, 2 a solution? Because this line is solid, it happens to be true for this line. But because this line is dashed, we know it can't lie on that line. So it's actually no solution at there, at 2, 2. Just something to think about. Okay, let's move on and do some more examples. So again, I want you guys to try these on your own, having done one example, and then I will show you the answers. You can kind of go slow and put my video on, and I'll come back on, show you one, and then you guys can try the next one, and I'll show you that one. All right, so when you look at this problem here, we know that we have a point 3, -1. When we graph that point, we apply 2/3 slope. We've got this red line here. Our purple line is y equals 6, or x is less than 6, so we have right here. And then I shaded according to the line I was talking about. So if you plug in 0 here for the top line, we know that 1 is greater than -2, and that is true. So we're going to shade above it, all in red. And we know that when x is less than 6, it means it's to the left, and so all of this is shaded. So the feasible region actually doesn't include this part or this part. It's only the part where they both have solutions. So this is our feasible region here, and anything over here can be a solution. Pause the video and then try the next one. All right, so here we are again. We've got the top line that I did in purple. When you tested a point on the top line, you should have gotten 0 is greater than 20, which is false. So we know the solutions don't lie where 0, 0 is. They lie on the other side, so all over here. Y is less than 1, so when y is always 1, we graphed that here. And 0 is less than 1, that is true, so we graphed underneath. So the feasible region for this problem is down there in the bottom right, where both of them are true. All right, let's go on to the next one. This is our last problem that we have, so we're going to graph the feasible region between these 3 lines. So first of all, we have our point -1 and 2. So we're going to go -1 and 2 and apply the slope of -1, 4. So down 1, 1, 2, 3, 4. Down 1, 1, 2, 3, 4. And we've got a dashed line. Let's see how fancy. Ooh, I can make that. Okay. And then we will test solutions in just a second. As far as this one goes, we know that when x is 0, y is -2. So we'll have when x is 0, y is -2. And when y is 0, x is 2. When y is 0, x is 2. And so what happens there is we will do a dashed line as well. And then we have our last line we'll do in blue, which is x equals 8. So 1, 2, 3, 4, 5, 6, 7, 8. And that one is a solid line. Okay. And then we need to graph the feasible region. So to graph the feasible region here, we want to know where x is 0. 0 doesn't lie on any of these, so we can go, that's a good point to test again. So we'll have -2 on this one, and then is greater than -1/4 times 1. So is -2 greater than -1/4? No, it is not. So we are going to shade on the upper part of the purple line. So let me get this. And then go ahead and do the other two. I'm going to get cut off in 45 seconds, so I'll just come back and show you guys the answers in just a second. All right, so here we are again. You guys can see that there's 2 intersecting here, but there's not all 3 solutions that lie there for all 3 lines. There's only 1 here, and then this guy doesn't work. So we know that our solution set lies in here in the middle. That's our feasible region. So of course, when you talk about 1, 2, 3, 1, this is not a solution because these are dashed lines.